An AI agent just tried to delete your production database. Not in a test environment. The real one. And the only thing that stopped it was a 200-line open-source library that nobody's talking about yet. This is Guardians. And if you're running any kind of AI agent that touches real systems, files, APIs, databases, shell commands, you need to understand what this does before your agent does something you can't undo. So let's talk about what's actually happening here. When you give an LLM access to tools, and that means anything from browsing the web to writing files to calling external APIs, the model decides which tool to call and with what arguments. It reasons, it picks, it executes. And most of the time, that works fine. But LLMs hallucinate. They misinterpret instructions. They sometimes take the most direct path to a goal in ways that made sense in their training distribution but are catastrophic in your specific context. And without a verification layer, that tool call goes straight to your live system. Guardians sits in between. It's a middleware layer, a firewall, basically, between the LLM's decision and the actual execution of that tool call. Before anything runs, Guardians checks the call against a set of policies you define. Is this tool allowed in this context? Does this argument match expected patterns? Is this operation reversible? If anything fails the check, the call is blocked. The agent gets an explanation. Nothing breaks. The way it works technically is elegant. You wrap your tools with Guardians decorators. You define Guardian policies, these are structured rules, not vibes. Things like, this function can only receive strings under 500 characters. This API call cannot target production endpoints. This file deletion requires explicit human confirmation. And then when the agent runs, every tool call passes through that verification step before execution. It's synchronous. It's blocking. It happens before the damage. The demo that's on GitHub shows this with a realistic agent workflow. The agent is given a task, it decides to call a shell command, Guardians evaluates the call against the policy, flags it as potentially destructive, and returns a structured refusal back to the LLM. The agent then tries a safer alternative. That loop, intercept, explain, retry is exactly how you want AI agents to behave in production. But here's the thing, Guardians is not magic, and it has some real limitations you should know before you get excited. First, the policies are only as good as what you write. If you don't anticipate a dangerous pattern, Guardians won't catch it. It's rule-based verification, not autonomous threat detection. A sufficiently creative prompt injection could produce a tool call that technically passes all your rules but still does something harmful. That's not a Guardians bug, that's a fundamental limitation of any policy-based system. Second, it adds latency. Every tool call now goes through a verification step. For most use cases that's milliseconds, but in tight agent loops with dozens of tool calls per minute, it adds up. There's no async verification path in the current version. Third, the policy language, while clear, requires upfront investment. You need to think carefully about what your agent is allowed to do, write those rules explicitly, and maintain them as your agent's capabilities evolve. Most teams building AI agents right now are not doing this work, which is honestly part of the problem. And fourth, Guardians currently operates at the call boundary. It doesn't understand semantic intent. It checks the shape of the call, not whether the overall plan the agent is executing is dangerous. An agent that makes 10 individually safe tool calls that together constitute a harmful action won't be caught by Guardians alone. What surprised me is how much room this approach has to grow. Right now the policies are static, you write them ahead of time. But imagine a version where Guardians learns from your agent's history. It sees that certain argument patterns always precede failed executions. It starts flagging those proactively. That's reinforcement from operational data, not just rule authoring. There's also a strong case for Guardians becoming a shared policy registry. If you're running multiple agents across a platform, say, a dev team with 5 different AI assistants all touching the same codebase, you want centralized policy management. One place to define what any agent is and isn't allowed to do. That's a natural extension of what's already here. And the integration with human-in-the-loop approval flows is underexplored. Right now, a blocked call returns an explanation to the LLM. But you could route that to a Slack message, a dashboard approval button, a mobile notification. The agent pauses, a human approves or rejects, execution continues. That's enterprise-grade AI safety, and the scaffolding for it is basically already in Guardians. So why does this exist? Because the AI agent ecosystem moved faster than the safety tooling. In 2023, giving an LLM a calculator was impressive. By 2024, agents are writing to databases, sending emails, deploying code, calling payment APIs. The capability gap between what agents can do and what we have to verify they should do became enormous, very fast. And the default in most frameworks is, trust the model. Guardians exists because one team got burned or came close enough to it and decided to build the guardrail before it happened again. That's the right order of operations. And frankly, it's rare. Most AI agent projects ship the capability and add the safety layer later. Sometimes much later. Sometimes after something goes wrong. If you're building anything with tool calling agents right now, LangChain, AutoGen, custom pipelines, doesn't matter, Guardians deserves an afternoon of your time. Link is in the description. The GitHub is well documented, the setup is fast, and even if you don't adopt it directly, the mental model of thinking and verified tool call policies will make your agent architecture more robust. Next episode, we're looking at a project that uses AI to audit its own outputs, a self-checking loop that catches hallucinations before they leave the system. Subscribe so you don't miss it.